All right, so number 66. It says basic answers to questions 66 through 68 on the topographic map below and on your knowledge of earth science. The map shows an eroded drumlin at Chimney Bluff State Park along the shoreline of Lake Ontario, east of Rochester, New York. Lines A, B, and C, the reference line. Elevation are shown in feet. So that's important because that gives us the units for elevation. We know that all of this is in feet. And if you are ever confused about what the units are, you could always look at the counter interval for elevation. It also tells you it's in feet. The counter interval tells you how much each line is going up or down by. So that is something to definitely keep in mind. So it says number 66, calculate the gradient along the line points A and B in feet per mile. So therefore, when I look at our reference tables, what page has the formula for gradient? And it states it right here. Change in field value over the distance. When we're dealing with topographic maps, the field value that we're talking about, the change in field value, is the same as the change in elevation. The field that we're talking about is elevation in feet, all right, over the distance, how far apart these 2 points are. So now when I look again, and I look at A and B, all right, so when you take a look at A and B, it tells us that A is at 300. So we know that A is at 300. This black line says that it's 350. And so therefore, if this is 350, and each line is going up by 10, this line is 360, and B ends up being 370. So A is 300, and B is 370, okay? So I already know the first part of my problem. I already know that is going to be 370 minus 300 for the change in field value. Now I need to know the distance, all right? I'm going to use my scale here to find out how far apart they are. Remember, the formula that we just stated is right here. Change in field value over the distance for the gradient. We already have our change in field value, which is here, and we're looking for the distance. That's what we're looking for. All right. So therefore, I'm going to take A and B. All right. I'm just going to clear everything. Let's clear everything. So I'm going to take A and B. So I'm going to, you can use this with a paper. All right. This is as accurate as I can be. And what I'm going to do is, based on that piece of paper, I'm going to check it with the scale for A and B. So if right here is 0.5, this lets me know each line is going up. I see 1, 2, 3, 4, 5. That means each box is going up by 0.1 miles. So therefore, my distance is going to be 0.1 miles, right? As we see right here, it covers a little over 0.1. I mean, if I move it, right? Basically 0.1, maybe a little over 0.1, all right? And so now I'm going to use 0.1 as my distance. Now, when I go back to my reference tables, remember, what was my change in field value? It was 370 minus 300, and this is in feet, divided by the distance, which was 0.1 miles. When you do the formula, 370 minus 300 gives me 70 divided by 0.1, and you end up getting 700. Remember that it's feet for my numerator per miles because my distance was in miles. And so that would be your gradient if you got 700. Now, your numbers could be a little bit different, you know, if you use 0.12 or 0.13. So here is your answers that is acceptable that you could have gotten. So the reference tables would have allowed any answer from 636 to 778 feet per mile. Now, usually you would have to include units, but the answer booklet already provided the booklet for you right here. All right, so once again, you could have said any answer from 636 to 778 feet per mile. The answer I got was 700, so it fits. And they're only looking for one answer. If they don't ask for a range, you don't put a range. Now, 67 is going to be a little bit difficult for me to break down, but I'm going to try as best as I can. So 67, it says on your gradient answer booklet, it says construct a topographic profile along line CD by plotting the elevation grid of each contour line that crosses line CD. The elevations for CD has been plotted on the grid. Connect all 9 plots from a line from C to D to complete the profile. All right. So what you're going to do is you're going to take a scrap paper. All right. And on the scrap paper, you're going to, which is what I'm going to do here, you're going to draw on the scrap paper the same line, from C to D. All right, the same line from C to D. Right. Now, what you're going to do is you're going to mark the value. You're going to mark the value for every iso line that crosses C. So the first point of C is 310. How do I know that? Because of the fact this black bold line is 300 and each line goes up by 10. So that's 310 here. So 310, 320, 330, 340, 350, 360, 370, and then there's 380, there's a big gap, and 390. When you've marked every number, what you're then going to do, you marked every number on your scrap sheet, is now you're going to plot each of those points on your line. Okay? So let me see how I'm going to be able to do this. Okay. So what you're going to do now is we're going to move the line down. All right. And remember all the things that you plotted, right? Remember how it was, now when you place your scrap sheet underneath, right? You had 320 here, you had 330, you had 340, you had 350, 360, 370, and then there was a big gap, right? 380, and there was a big gap. So your plot is going to show that. Your plot also has to show that as well. So when you're plotting, right, your plot should look, and I'll show the answer key. Your plot should look like this. Remember how there was a big gap between 380 and 390? So you want to plot that as well, for number 68. I would encourage definitely YouTubing how to draw a topographic map profile. YouTube this, and there are many excellent videos that can help you if you ever come across how to draw a topographic map profile. All right. Now for number 68. For number 68, it says, describe one piece of evidence represented by the contour lines on the map that indicate the north side of Chimney Bluffs is steep. So the north side, so this is the north side of Chimney Bluffs. How do we know that it's steep? What is one thing that is very interesting about these lines, right? That's located right here on the north side. It's the fact that there are many ISO lines that are together. When you have a lot of ISO lines that are close together, that represents the steepness. So on our answer key, if you mention that the ISO lines or the counter lines, if you say the ISO lines or the counter lines are close together, that lets you know that it's steep. If you said the spacing is small between the counter lines, that is fine as well. If you said there's a great change in elevation in a short distance, that's fine too. But if the counter lines are very close to each other, right, that lets you know that that landscape is steep when the counter lines are close to each other. All right.